Welcome to Ask and Learn.
Okay, so for this problem, we're going to prove that n equals mi plus 1 and L equals n minus 1 times I plus 1 is true. So for the n equals mi plus 1, so if we break this down, Theorem 3 shows us that the number of vertices is built from each internal vertices having m children plus the root. So we have m children per each internal vertice. Okay, and then we have plus our root. So that one naturally proves itself. So for the second one, which I'm going to do in green, and this is part A. So for L equals n minus 1I plus 1, we know that n also can equal L plus I, which is the number of leaves plus the internal vertex. So if that's the case, I also know that n equals mi plus 1 so I can subtract I from each side. And then I can factor this out. So I'm going to have m minus 1I plus 1. And then for part B, we are asked to prove that n equals ml minus 1 over m minus 1, and I equals L minus 1 over m minus 1 is true. Okay, so I can use both of the equations from the part I just processed, from part A. So what I'm going to do is I am going to do L equals m minus 1I plus 1. I am going to subtract, so I'm going to try to solve for I. So I'm going to subtract 1. And then I can divide by m minus 1. So that's the first part. So now to prove that n equals ml minus 1 over m minus 1, I can go ahead and use my n equals mi plus 1. And I know that my I from this problem, I can use it. Plus 1. So I'm going to go ahead and multiply. So this is going to be ml minus m over m minus 1. And then I can also take this 1 and I can rewrite it. So I want to have the same denominator so I can combine these. So I'm going to put it as m minus 1 over m minus 1, which is still 1. And then I can combine these. Minus m plus m minus 1 all over m minus 1. And if we notice, my m negative minus m plus m cancels. And so I am left with what we need, ml minus 1 over m minus 1.